Pick up any rock and you're holding a piece of deep time. For most of human history, nobody knew how deep. In 1650, an Irish archbishop crunched the numbers and announced a date, 4004 BC. He was off by 4.54 billion years. So how do you actually measure the age of a planet under your feet? By the 1800s, physicists thought they had it solved. Lord Kelvin calculated Earth's age using one simple idea: molten rock cools over time. He measured the cooling rate and landed on 20 to 40 million years. Geologists hated the number. Darwin hated it more. Evolution by natural selection needed hundreds of millions of years to work. Kelvin's Earth wasn't old enough. Then, in 1896, a French physicist named Henri Becquerel found something strange in a drawer. A uranium sample had fogged a photographic plate through solid paper with no light source at all. He'd stumbled onto radioactivity. And radioactivity broke Kelvin's entire calculation. Rocks weren't just cooling. Deep inside the Earth, radioactive atoms were quietly generating heat of their own. In 1904, physicist Ernest Rutherford stood in a lecture hall and explained why Kelvin's number was wrong, reportedly with Kelvin himself sitting in the front row. Suddenly, Earth had an unaccounted-for power source and an unknown clock. Here's the strange part. That same flaw became the solution. Radioactive elements decay at fixed, unchangeable rates. Uranium becomes lead on a schedule that never speeds up or slows down, no matter the heat, pressure, or chemistry around it. Measure how much uranium has turned to lead in a rock, and you're reading a clock that started ticking the moment that rock formed. There was just one problem. Earth keeps recycling its own crust. Plate tectonics melts, folds, and destroys old rock, erasing the oldest clocks. So if the ground beneath you keeps rewriting itself, where do you find a clock that was never touched? Scientists looked somewhere it could never be reset: outer space. In 1953, geochemist Claire Patterson turned to meteorites, debris left over from the same swirling cloud of dust that formed the Earth itself. Untouched by tectonics, a meteorite's clock had been running since the solar system's birth. Patterson measured the lead isotopes inside the Canyon Diablo meteorite, wreckage from Arizona's meteor crater. In 1956, he published a number: 4.55 billion years. Modern measurements have barely moved it. Today's figure? 4.54 billion years, accurate to within about 1%. Think about what that means. Every rock beneath your feet, every mountain, every ocean floor is built from atoms that have been quietly decaying since before there was a sun to set. You didn't inherit an old planet. You're standing on a clock that's been running since the beginning of everything.